Hi guys, everyone. My name is Edwin. I'm from TopTireReview.com, and yeah, I'm a former tire engineer, and yeah, I'm here to answer questions from my good friend Ali. So let's go. So first question. Thanks. I was wondering about three things. First, the wider a tire is, the more it struggles with water evacuation. In a temperature climate and for regular everyday driving, what is a tipping point under which it doesn't really matter which where your tire is summer or rain because it wouldn't really aquaplane anyways? So this is a tricky question. So of course, the yeah, it's not actually depending on width. It's actually depending on how your contour is. So when I talk about contour, you can imagine the easiest principle: a bicycle tire or a motor tire. It's very curvy, and these are the tires that actually are the best in aquaplaning. Behind this is very simple. If you have a curved tire, so a curved shape, water actually hits the front first, and then it takes a few milliseconds later to hit the back. And this allows you to dissipate much more water faster. But if you have a very flat contact area, you hit the tires actually at the front or at the same time, so you have no chance to actually evacuate water uh, um, quickly. So second, rally cars use very skinny profiles for snow, but is a smaller size also a good idea on regular snow tires? Not really. So I think the rally cars use very skinny profiles because they are using studded tires. And for studded tires, the higher your pressure, which is skinnier, the better it is for them. So they can exert much more stress, they can exert much more force onto the surface. So that's why a smaller contact area that you get from skinny profiles are actually better. So, and finally, weirdest of my weird questions, not weird at all. Michelin is developing the Aptis and airless tire. Can we expect more precision in driving experience from increased lateral rigidity, or we will have perverse effects? If you ask me, if I understand it correctly, airless tires actually much more circumferential stiffness. So, which means that you are actually laterally really weak, So, um, unless you have a certain angle where you do have a resultant lateral force, but overall, handling should be much more worse for airless tires. So, um, do you think airless tires will be widely used at some point in the future, or how much development it will take? For me, actually, the main reason right now it's not mainstream probably is because of cost. And of course, there is some concerns about, how do you repair these tires? And of course, one of the biggest drawback is what happens to the dealers when you have airless tires. So you don't have to change them anymore. Probably after wear, but yeah, if the cost is low enough, I'm pretty sure there is some takers, especially when it comes to new technology. Okay, there's this new Goodyear green tires made out of vegetable material. My question is, if I get a puncture, would I still get to repair them with the current techniques like vulcanization, cold and hot patches? For sure. I think the key concept of vulcanization would not will still be the same because it's rubber, but vegetable material only takes a certain percentage inside the tire. So the key bonding must be still rubber or synthetic rubber, yeah, with sulfur. That's a key to this very long polymer chain. So next question, when you have the when you have the possibility to choose your new tire, how do you proceed to know it's the absolute best one for your needs? So this is a question that I get a lot. The idea is you need to ask you what is your requirements. So if it's your requirement, so there is one of the most obvious requirements is safety, which comes in the form of wet braking. While in Asia, there's also a big requirement for noise and comfort. So first, you need to know what is your requirement, and then second, what tires actually meet your requirements. Tire is a very complicated thing where you cannot get a you cannot have everything that you want. So there is always a target conflict that exists, and you need to know which tire are able to solve this target conflict at a very high level. So what does this mean is, for example, wet braking versus wear. So both of them are a classic target conflict. A very good wet braking tire usually will not perform very well in mileage, but yeah, for good brands like Michelin, they are able to solve this at a very, very high level. So probably get a very good wet braking and still reasonable mileage. So my question is there a possibility for us to move to airless tires? Yeah, this we have already discussed. Do you ever see these airless tires catching on whether it's racing or normal use? Yeah, I don't think so. It would ever go to racing because of the lateral stiffness. You have basically much, much lower lateral stiffness than the current standard tires. Why does Pirelli test their tires at the end of every year, even when the tires will be the same in the next season, except for major upgrades like last year? Also, do you think multiple compounds of tires needs a comeback in F1? My guess is why Pirelli is testing the tires every end of the year is because they are actually trying different formulation. So it could be looking at different improvements in terms of wear, or look at where degradation happens a lot in whatever laps, whatever circuit, and try to address them with an upgrade. But nonetheless, as you know, Pirelli is the major supplier. I don't think there's much competition. So multiple compound of tires need a comeback. I think there's right now 3 compounds in F1, no? Soft, hard, and soft, medium, and hard, So yeah. How do you make the rubber different softness grades, So to make different softness, I think there's a lot of ways, You can add oil, you can add softener, or you can also add, you can reduce the glass transition temperature. So different ways. How much does these tires last, and how expensive are they? Are we talking about F1 tires? I saw a video the other day where it says an F1 tire costs 700 pounds. Not really sure about the numbers, but 700 pounds, yeah, sounds about right. Will be possible to create tires which have high performance but low optimal temperature. Yeah, 30 to 40 degrees Celsius. For sure. I mean, just look at studdless tires or winter tires or Nordic tires. They are running at a very even much lower temperature, but greatly suit to the weather conditions. So, which brand provides the most durable street car tires? How to select the correct tire type for regular use? So I think I mentioned before about how to select tire types. You have to. So tire types. So I think there is a lot of different tire segments around, so people probably get confused. There is all season, there is all terrain. So in this off-road, on-road side, there's like 3 types of tires. There's all-terrain road, ATR. There is also AT, all terrain, and then there's also MT, mud terrain. And then when it comes to summer tire, there is, I don't know, summer tire, ultra high performance tire, and then this ultra high performance tire. So lucky for you, most of the time it would be depending on your weather conditions. So when you have an tire size, or when you buy a vehicle, your tire size is more or less fixed, and unless you want to change them. But if not, you probably have an option of two different segments. So for example, if you are a normal passenger car, probably you have a summer tire option, and then you have an all-season option. So that's it. You just have to base on your weather conditions. While if you are in a truck or big tire size with high aspect ratio, so you probably get to choose these three all-terrain options. So you got to know whether are you, so for example, ATR, so all-terrain road, is 70% on-road, 30% off-road. For all-terrain is 50% on-road, 50% off-road. For mud terrain is defined as 70% off-road, 30% on-road. So you have to really gauge what is your daily usage and what is your road conditions and decide from there. Does low profile tire actually improves handling? Yeah, for sure. Handling, so the stiffness of your sidewall determines how well and how fast your tire turns, They call it the cornering stiffness. And the stiffer you are, the faster it turns. And basic maths, a lower profile tire is actually much more stiffer than a high profile tire. So yeah, it actually improves handling. Its friction depends on the coefficient of friction and normal reaction only, not the area of contact. Why are wider tires deemed gripper than slimmer ones? So this is a common misconception. So two things first. If your contact area doesn't change if you maintain regardless of your tire size. So a lot of people was asking, oh, if I go wider, do I get bigger contact area? No. So what you change if you maintain your air pressure the same. So because your load is the same, your air pressure is the same, you get the same contact area. But what change is your contact area profile. So one could be shorter in the front and longer, or one could be very wide and short in terms of length. So there is a certain advantage if you are wider. So the wider you are, the better for wet braking and better for snow. While the wider, while it's totally disadvantage when it comes to noise. So these things you have to keep in mind. Have you used other metals for tires other than steel, like copper belted radius or aluminum belted radius? I think probably they have tried. So copper, very expensive. Aluminum, also I won't say expensive, but less strength. So in the end, steel is the cheapest and the strongest, unless you have a requirement of weight, Okay, so let's move into more on F1 tires. So do you know what actually differentiates soft tire to medium and medium to hard in F1 tires in terms of compound/material? And how does that difference affect the length of tire life? Okay, if you ask me exactly, not sure, but I can give a guess, So probably they adjust how well, so they adjust the same things that I mentioned before, softener, oil content, and also the glass transition temperature. So you can imagine soft tires, soft, medium, hard, to a similar analogy, like winter tires is soft, all season is medium, and hard is summer tires. So the softer you are, the higher your micro contact area is, depending on your glass transition temperature. But in general, this is why soft tires actually get much more grip. But when your compound is softer, your, let's say, your abrasion resistance actually reduces a lot, and that's the reason why soft tires actually have very short life. Very simple. You want soft to stick on the surface, but then you get smashed because of all this wear that you are, and because you are not as wear resistant, or your abrasion of resistance abrasion is much lower compared to harder tires, you get smashed in mileage. So how do you estimate or calculate the degradation of tire during a race? I can probably guess this. You need to know. So imagine you calculate you do 5 to 10 laps, and you measure your tread depth reduction of your tire, or you can also measure the weight, and then from there you can back calculate how much degradation you have. I think that's how well they calculate. I mean, obviously in real time it's even more difficult because I don't know, maybe you are overtaking and you cause certain hot patches which affects your degradation over time. So in a constant, let's say in a qualifying lab, I'm pretty sure this can be calculated very easily. Does street tires last longer than racing tires, especially F1s? Yeah, for sure. I think racing tires, F1 tires are actually designed for maximum grip without much trade-off of mileage, while street tires definitely have mileage in mind when they design. So that's the common trade-off. What allows some compounds of tire F1 to be more grip and durable than others? For example, hard tire is very much durable and can last much longer than the soft tire, but loses out in soft. That soft offers more grip. Yeah, this is exactly what I explained previously. Softer tires has much more higher micro contact area, but a very low wear resistance compared to harder tires. And as everything in the tire life, everything's about target conflict and trade-offs. So yes, I know F1 cars wear intermediate wet/wet tires, and do I know the fact that these tires can absorb a couple gallons of water and they can also release it at the same time? So how can it work like this? I won't think these tires absorb the water, but they disperse the water really well. And yeah, wet tires and intermediate tires are actually much more harder than your typical hard tires, and that's the reason why they are quite wear resistant. On top of that, they have a pattern which helps them disperse water. And to be reminded, aquaplaning is always a function of speed, and that's the reason no matter how much water you disperse, if you are too quick, you're gonna aquaplane. So that's one thing. What do racing teams do with old tires? As I understand, Pirelli actually takes back all these old tires and then take them to, I think they recycle them, no? This I have to check again. Why do some teams struggle for tire temperature? I think this has to do with the amount of downforce you create. The higher your downforce, the more temperature you get, or maybe you take more laps. But the higher your temperature, the better it is for traction. or basically grip, I think every tire is designed to work at an optimum temperature, and you have to hit this temperature before start reaping the rewards. If not, it's like you can imagine the same analogy, if you are not getting into temperature, you probably are driving a summer tire in a winter condition, while once you hit a certain temperature, you have this incredible micro grip, and you are like a winter tire in a winter condition. With F1 bring back multiple brand options? Yeah, for sure. Um, I'm pretty sure. I think Michelin pulled out from this tire war against Bridgestone at one point because they do not see any competition. No, so Pirelli has it easy for themselves. No improvement needed, and yeah, there is there should be another competitor, just like there's different teams, but unfortunately, I think different tire brands create higher complexity, and this would create much more costs. And this is something that I think F1 doesn't want right now. So they say that tires have been made less durable for the entertainment in F1. If so, how durable can the tires be made, and how much would they affect the performance? Keeping that Le Mans Michelin tires in mind. So I would not say tires are made less durable for entertainment. There is always a trade-off between tire degradation and changing tires. No? So obviously, if you calculated your lap times and you are a couple of laps to victory, a lot of people opt to risk it or rather than doing a tire change. So this is actually for me in terms of a risk benefit, and I'm pretty sure all Pirelli tires or F1 tires have to pass certain tests, certain structural tests or force before actually giving it before actually being approved. So yeah. So let's move on to more personal. So yeah, why are tires round? Yeah, for obvious reason. Round creates a perfectly round tire actually only has one contact point, but obviously rubber actually creates a contact patch because it's viscoelastic, and that's where you get your traction and braking. No contact area, no braking at all. Why are tires black? So tires are black because of carbon black. It's a filler that improves the strength of the rubber. Interesting fact, if you look at tires predated before the carbon black revolution in 1900s, all tires are actually white. So more of a personal note, is mechanical engineering hard? Do you need to be good at math? Why do you go into engineering? So for me, mechanical engineering is a it's let's say it's not hard. I have a big interest from start, but mechanical engineering is actually a very good pathway to many industries. So if you take a helicopter view, a lot of people think mechanical engineering is only automotive, cars, motors, but actually mechanical engineering has more than that. Anything that moves is part of mechanical engineering behind. So like air cons, so fluids that move and being compressed, that's mechanical engineering. Anything that's static that has a cover or plastics. So for example, a bottle cover, you need a mechanical or slash material person involved. And on top of that, for example, a design of a kettle has to be done in parts like mechanical engineering, and also aerospace. So mechanical engineering also has a subset in aerospace, and these are all intertwined. So it gives you a very good base. let's say, to join multiple industry in the future. Do you need to be good at math? I wouldn't say so, but you need to know how to count. That's it. Have how to solve equations for sure. And yeah, that should be it. I mean, you don't need to be a genius in math. So Dr. Pang, possible to share where you studied and your journey to PhD? Any reason why you're not in F1? And which F1 team are you a fan of? So I did my PhD in University of Nottingham. So when I finished my master's, I was looking for a job. My professor was telling me that why not do a PhD? I said, oh, PhD, treat it as a job. By end of your job, you get a PhD for free, and on top you get paid as a stipend, and you get to work and treat it as a work, gain experience, and by end of the end of your study, you get a PhD. And of course, that sounded very nice. And it is exactly like this. And on top of that, you get to work with and collaborate with different industries as your partner, and it's a really valuable experience. That's where I learned how to do proper research and development. Any reason why you're not in F1 yet? So, to be honest, I think there's only a fixed number of F1 engineers out there, F1 engineer position out there. And you need to be the top of the top to be there, to be involved. And most of the let's say engineering game right now in F1, it's mostly got to do with aerodynamics. And I'm not a big fan of aerodynamics. And which F1 team are you a fan of? I actually like McLaren a lot. So I was a big fan of Mika Häkkinen since 1998 when he won the World Championship twice. And yeah, I know we have suffered a big drought, and I was really happy when Lewis Hamilton won in 2008. And then you get a couple of years of small wins, and then I was really jubilated when Daniel Ricciardo won. Was it last year? Yeah. It's a really, really, really long time since we last won. So last question, you're probably tired of questions about tires. So what's your favorite ice cream flavor? My favorite ice cream flavor is pistachio. So I like pistachio a lot. And yeah, so that's about it for putting up the questions. And I really had a good time enjoying answering them. Thanks, guys. And if you're free, feel free to drop by at toptirereview.com and learn a few things about tires. Thank you. Have a good day. Bye-bye.